you guys to pick up the skill sets to solve the real problems. So today we are going to have 2 training sessions for you. In the morning is about natural language processing. So definitely it's very useful. And in the afternoon, we have a deep reinforcement learning, which is very sexy and fancy. It has a lot of potential. And I cannot wait to introduce the instructors of this morning. So SK are ready. So Mr. SK is a techie and entrepreneurs. And currently he is a chief product officer in digital group and network. And before that, he was a co-founder of a few startup companies. And he was in Apple company for a few years doing product management. He is also the blog writer, covering a lot of hot topics, AI, machine learning, NLP, IoT, also the recommendation systems. So ladies and gentlemen, let's welcome SK to teach us how to deal with NLP.
Thank you. Thank you. Thank you very much. Good morning, everyone. Thank you for coming for this session. I'm very excited to talk about this. Before we get into the topic, a few announcements, kind of. I tend to speak very fast. If you see me talking very fast, please let me know. I'll slow down. Second, I guess you know the location of the restrooms and outside stuff. If you have any charging problem, the gentleman Mike there at the end, you can flag him and maybe he can help you with the charging and any stuff you're going on. Let's talk about the biggest focus, the installation of the software and files which I had sent. The instruction email was sent yesterday night. It was purely my mistake. It's not the organizer's mistake for the delay in sending it to you. If you have installed the PyCharm and Anaconda, that's fantastic. Or if you have other tools, open source tools which you're using to run some Python files and the Jupyter Notebook files, that's fine too. But most importantly, please don't worry about if you're not installed completely or if the files are not running on your computer. We will be having the video recording of this session posted, at least on my personal YouTube channel. You can go back and look at that, and the files you have downloaded, you can install it correctly later on and then work on it. The reason for that is the most important fact of NLP and the most important takeaway for today for all of you is to understand the concepts in NLP. Those are a little bit difficult and the most important ones too. Because of the advent of so many frameworks coming in, programming NLP solutions is becoming easier and easier. There will be a day eventually where it becomes almost trivial. But for picking the right model, right hyperparameters, right way of training, right type of data, right type of looking at the data, all of these needs understanding NLP conceptually. And you need to do a little bit of out-of-box thinking sometimes too. And sometimes the data doesn't show you the right solution, a right path, and you got to look for different data. And before I start NLP, I want to tell you a story. You guys like stories? A few years ago, the Pontiac division of General Motors company got a mail from one of the new car buyers. The complaint the customer had was so silly that they just threw the letter away. They said, it's some prank. The customer wrote another letter 2 weeks later, and he explained again, you know what? I have sent a letter earlier, you did not respond. I can imagine it sounds very silly. For me, even it's silly because here is the problem. Every night after dinner, we as a family go to buy ice cream from a nearby ice cream store, come back and eat ice cream. We buy different type of ice creams every day. Sometimes it's vanilla, sometimes it's something else. But here is the interesting part. Every time we buy vanilla and get back into the car wouldn't start. Every other ice cream we buy, the car starts perfectly fine. We come home and eat ice cream. And I thought it must be just a fluke. So I tested it multiple times. And it happened so many times, now I think it's a concrete evidence that there is a ghost in my car which doesn't like vanilla ice cream. So if you get that as a data point to do an analysis of what's happening, what would your response be? Collect more data. Okay. Yeah, I know this is not an NLP problem, but the point I'm trying to make here is sometimes when you look at the data, you just wouldn't get the story by just looking at the data. You've got to do a little bit of processing of the data. Anyway, so Pontiac division, they said, okay, we've got to find out what's happening. So they sent an engineer. Are you all engineers? Okay, good, good, nice. I like engineers. I'm an engineer too. So what would the engineer do? He goes and verifies whether the complaint is correct. So every night, he takes a ride with them, go to the ice cream place, and then come back with them. And lo and behold, every time they buy vanilla ice cream, the car wouldn't start. So the engineer is now confused what to do. But then, being an engineer, you just can't believe there's a ghost sitting in the car. So he started making notes. He actually started collecting data. What time we left, what time we reached, what's the distance, how long we stayed there, what is the weight, number of people in the car, is there any problem in the pollution or whatever of the car. After a few days, he figured out one anomaly in the data. Every time they picked up vanilla ice cream, they come back into the car within a few minutes. Every other ice cream takes a long time because vanilla ice cream is the one which is so popular. They keep it just outside near the door of the store. You just pick it up, pay, and get out. Whereas all other ice creams, you got to go inside. He said, okay, now I have a different data point. The time it takes from the time you turn off the engine to turn on the engine is different the days you buy vanilla ice cream versus the other ice cream. So it's no more ice cream problem, it's just a vapor lock problem. If you turn the engine on immediately after you turn off, there's a vapor lock and an engine wouldn't turn on. So, welcome to NLP. I would be talking about so many different concepts that's being used in the last 2 or 3 years. And when you are presented with data, you would be using these concepts to find solutions. You could be working for a healthcare company, you could be working for a hospitality or transportation, manufacturing, port management, energy trading company. It could be any company, and you have a variety of data. You could have statistical data, you have the textual data, you have the image data, and then you have the audio data. Some of the concepts we'll be talking today will be also applied in a little bit of image processing and a little bit of audio processing, but we will be focusing more of text processing, natural language processing. One more time before I get into the presentation, if you are not able to install, if you are not able to run the applications along with me, don't worry. Focus on the concepts, and you can always run them when you go home because we'll be having the video recorded, posted maybe in a week or two, not more than that, maybe a week. I want to share the PowerPoint after the presentation is over because based on the feedback I get, I normally update it, make it a PDF, and share it with people. There's a lot of information. Sometimes it's not useful. I may not be covering all the stuff I have. I actually have 8 hours worth of stuff, and we have only 4 hours, and after that you got to leave, I guess. Yeah, you can't be looking at my face for longer than 4 hours. So I'll not be able to share the PDF, PPT right now. After that, we'll be. So when I uploaded the YouTube video, I'll also have the PDF file uploaded. So that's my company. So these instructions you already seen. You have installed NLTK successfully. This is the GitHub link. I think you may all have seen, and hope you have installed the files I mentioned there. So let's start NLP. Let me give an example of a statistical problem in machine learning. We may be solving one statistical problem too, just to talk about a Keras model, but let's say you are a retail company and you want to do an email campaign to attract more customers. And you collect data after the campaign is over to check how many people responded positively or not. And if your verification is how many people actually came within the first 2 weeks after the end of the campaign, and if that shows the success of your campaign, you want to find out, using machine learning, what factors facilitated, what factors did not facilitate. So the customer information like gender, age, location, spending habit, maybe job, you could have a 10, 20, 50 features that's being used. And you can use any of the tools you have, whether it's a support vector machines or boosted trees and XGBoost, whatever. And the computer can process the number. But in text, you've got to do something different to process a text. And some of the problems you find in text is, actually there are a bunch of problems. Words sense disambiguation. For example, the paintings were stolen by 4 thieves. They were caught the next day. They is what? Are you referring to the paintings? Are you referring to the thieves? Similarly, pronoun resolution. That's pronoun resolution, and word sense disambiguation is, Donald Trump went to Asia along with his team. He met with the Prime Minister. Obviously, he here is Trump. So when you do an analysis of the text, you need to get out of that ambiguation, the ambiguities in the text. Now, what's the use case for that? Why would you want to do that? I'm facilitating, I'm actually an advisor for a startup company where they manage legal contracts. I was told big companies like IBM, Microsoft, Apple, Google, they typically have around 40,000 to 50,000 contracts every year. Now, you can't have a legal team of 100 people even to manage those contracts, especially if there's an actionable clause in a contract. You have to go back, you'll be having multiple people going back and reading the contracts constantly. They're developing an automated solution which will process all the contracts, identify actionable clauses, and based on relevant triggers, it actually takes an action. The action could be as simple as send an email to the legal team, or send an email to the CEO, ask the supplier for a penalty payment, or inform the vendor management to do an audit, whatever is the the actionable clauses. In such situations, you can use this type of processing of text. Of course, healthcare is a major investment focus area. If you really want to start a startup company, healthcare would be a good idea because you'll get funds immediately. Because every venture capitalist is investing money in companies trying to do ML solutions in healthcare. And healthcare is a massive area where there's lots and lots of text being used, the unstructured text. When you go meet the doctor and you as a patient is discussing your situation and the information you're sharing with the doctor, many times the doctor is actually typing information. In the typing also sometimes he loses or he makes grammatical errors, he makes other errors, or he misses some information, he or she. And if you have such a text, which is not completely populated, sometimes erroneous, sometimes grammatically incorrect, sometimes some missing information, how would you process that to have an actionable item? There's a company in London, DeepMind, Google actually worked on, it's called, I think, Live Streams, if I remember correctly. They're working with a healthcare company based on the unstructured information of a patient. It sends an automatic information on a page to a doctor or a nurse or a pathologist or whoever it is based on the situation that the patient is going through, especially if the patient is in ICU care or some other care, based on the current information that's coming in, which actually helps in cost cutting and all that stuff. What types of processing can you do? There's so much of processing that you can do on the text, and almost all of this processing is automated now. You can just run a few API calls using some of the frameworks available. We are going to use one framework today, but there are other frameworks too, open source tools available. You can do the processing. But there's so many things. For example, tokenize. If you have a long text, you want to identify individual words. Each word would be a token. You want to stem. Stemming and lemming is a field where you can shorten the word to its root. When do you use that? You use it when you're doing a language translation or sometimes even summarization. I'll talk about that in my presentation today. But stemming, lemming is another one. Sentence segmentation. If you have a long sentence, you want an automated chunking or segmenting of a sentence into smaller pieces, which are many times grammatically correct. For example, I took a morning flight which normally departs at 6 a.m., which did at 7 a.m. today, and reached still on time to my destination. If that's a sentence, if I want to know what time was your flight departed, what time your flight departed today, if you do a sentence segmentation and then do a little more rules engine, you can actually find out what's happening. Word segmentation too, instead of a few words together as a sentence segmentation, you can actually find word and pieces of words being made into small pieces. Parts of speech tagging. Every sentence has a noun, verb, adverb, pronoun, preposition, so many of parts of speech. You want to identify what was the root word, and if the root word happens to be a verb, what was the subject that is working on the verb. For example, John went to the movies. Went being the verb, being the root. It says, okay, which word, what is the subject that's working on this verb? It actually recognizes that. I'll show you a picture of how graphically you can do a tagging, and then you can do a processing, or you can write a bunch of rules. Or John did not go to the movies. So you actually have the not modifying the go part. So you want to identify the verb and you want to identify the modifier of the verb to automate the processing of the text. Chunking is again, I think, identifying the pronouns and nouns in a sentence. Named entity recognition. If you have a big text, you want to identify names of people, names of organizations, names of locations identified, and you can do a little bit of a parsing on it. Now, if you know the name, why can't you just do a pattern recognition? You can do that too. But then, if you know the name, if you know what you're looking for, then you can go find using just a pattern recognition. But if you don't know what you're looking for, you know that some location is being mentioned and you know some person is being mentioned. Obama was the last president of this country, and if there's another sentence, Harvey Weinstein got into trouble. If you don't know what the noun you're looking for, then it actually parts of speech and named entity NER will help you. So there's so many other analysis. Co-reference resolution. I showed an example too. He went to the movie, and if you have a previous set of sentences, who is the he referring to is sometimes confusing, because you need to replace those references by the original subjects or nouns, so that when you pick only one sentence and process or take an action based on it, you have the complete information. You had a question?
Yeah. In the case of name recognition, can I update my own, suppose my company's name or my customer's name?
Yeah, you can train the library. Typically, you have NER, which is based on, let's say, NLTK or Stanford NLP. They all are trained to identify the most commonly identifiable names and locations and organizations, but you can also train further to make it specific for your organization, or with your names or your organization's names or locations specifically, yes. This is an example of tokenization. If you have a sentence, and I'll show you also, I'll make you do a tokenization example. But this is what typical tokenization means. You break the sentence into individual words and the other notations in the sentence. Lemming and stemming is this. If you have an original sentence, this was not the map we found in Billy's Bones chest. And when you do the lemming and stemming. It says, "Thee were not the map we found in Billy." Now, this is lemming and stemming, as I mentioned to you earlier, is used for when you're extracting intent and you don't know exactly what the intent is and you want to go back and verify based on the root word. You need the root words. Number one, when you're trying to do language translation and some summarization, you need to have the lemming and stemming. Yeah, those are the two use cases I can think of.
Many people know what stemming is. Lemming, you usually think of a small animal like a mouse. Explain more about that.
Lemming and stemming, I normally talk together. It's actually trying to bring the word to the root. I may have an example, and I'll talk about that lemming, what the lemming means. But I don't think I'll be able to explain it in words. Maybe if I show it to you. This is, I'm using Core NLP here. It's not NLTK. I've asked you guys to install NLTK. That's one of the older and a longer time NLP open source tool available. Standard Core NLP or standard Stanford NLP is also one. Stanford NLP uses Java, and I wanted to use Python also because of two reasons. One is, of course, my personal preference towards Python. Number two, if you look at all languages being used in machine learning nowadays, I think Python is the most popular in terms of number of people use, number of contributions, the richness of tools available, and the variety of frameworks that use Python. So that's the reason why I've used NLTK. But you can use Stanford Core NLP too. So that's co-referencing. It's identifying showed of his, and it replaces the word his with the name of the person who the sentence is referring to. This is basic dependencies, where it includes the parts of speech tagging, but it actually parsing the sentence to identify the dependencies. If you look at, I would give you a couple of seconds. Look at the sentence, President sorry, I cannot pronounce the name correctly. Xi Jinping of China, on his first state visit to the United States, showed off his familiarity with American history and pop culture on Tuesday night. It's a long sentence, multiple pieces of sentences there. If you look into how, and if you run this, there's a browser-based API for NLP, and if you copy-paste any sentence there, within a few milliseconds, you will find this type of dependency matrix identified. And you can actually use this to identify what's the root word, what's a verb, what's the preposition, what's the noun, what is modifying what is determining, what words determine what other words in the sentence. All of the information is provided right there. And then if you want to process it for your business use case, you have to write the appropriate rules and then and extract the words you're looking for. Open information extraction is another part of Stanford Core NLP tool. What it does is, if you have a complex sentence, it breaks that into tuples, mostly binary three tuples, which is actually a combination of words, which many times makes sense if you just read it independently. So that's the first step it does. So it breaks the sentence into 2 or 3 pieces, each piece being multiple words. And then from then it starts giving the bare minimum most important words which communicate the essence or the message in the sentence. Sometimes it gets it wrong, which is the case for every tool. But if you look at the starting sentence and if you look at the final 3 tuple words at the bottom, it captures the essence of the message. Sometimes if you have a long sentence, as I mentioned to you earlier, if you have critical 2 messages or 3 messages, it may lose that part. But if you have a single message in a sentence, it actually breaks it down very nicely. Parts of speech tagging, there are hundreds of ways of tagging. The coordination, conjunction, cardinal digit, determiner, existential there, foreign word, preposition, adjective, adjective comparative. There's so many tags available. So if you have a linguist in your organization because you have lots of text coming in and you want to process the text, and you can define a bunch of linguistic rules you want to, this makes it fantastically easy because the tool is giving you all the parts of speech tagging of a sentence or the bunch of text which you need to process. So if you are a manufacturing company and if you have information about your product, or if you are, there's a nice case study about, I think it's called Standards Organization, which publishes summary of 10K and 10Q reports filed by public companies. It actually does a summary analysis of how good the quarterly announcement by company ABC or the annual announcement by the company ABC is good. So it actually does the analysis and publish it. Right now they are doing it completely manual. So what they do is per month they can only do around 100 reports because they just can't afford to have more number of people. But after they started using NLP, which includes your NER and parsing and other stuff, they actually can do 450 or 500 reports on a monthly basis. So 5 times productivity. That's another use case you can think of if you can break the text down and process it using rule engines. When you download NLTK, I'm sure you all have done, NLTK is one of the most commonly used by many academics, and they've been using for the last so many years, I think 5 or 10 years at least. For you to do lots of experimentation, I think you should do it when you go home today, because you're so terribly tired of listening to me in the evening. Take a rest, but when you do it tomorrow or the day after, there's so much of corpus of information available, so many books and text available you can process. I think we're going to be using a brown corpus today for some of the processing, but there's so many books available, so much of text available. So if you want to do any type of processing, just experimentation, those are the resources available. Okay, so let's open a Jupyter notebook. If you guys have, what I'm going to do is I'm actually going to go to Anaconda, going to open a Jupyter notebook. Again, if you cannot do it, don't worry. The files are extremely simple files, and I'm trying to show, for at least for the next 2 or 3 hands-on activities, a very, very simple processing of text, just to show how extremely it is simple, even though it's using lots and lots of text. Sorry? For the Wi-Fi? Okay. So that's the password. Okay, you guys can take a picture of it so that you don't have to forget and stuff. Okay, let's go back. Okay, so what I'm going to do is I'm actually going to show you, so I'm importing NLTK. I've already done it a few times, so it may show that it's already done. Yeah, it's already done, but it takes 2-3 seconds to download. If you have not done it, what happens is when you said import NLTK, it actually has a pop-up screen asking you what type of resources you want to download. Say click all and button download, and it just takes 2-3 seconds, not more than that. The entire text will be downloaded there. Then what I'm going to do is, so I'm going to do this. Okay. I need a Wi-Fi. Okay, so this is the pop-up screen you get. The default is, I think, selected all. You can pick 1 or 2 if you want, but I would recommend select everything and click download. Okay, it just takes less than 2 seconds. So I do this, I go back. Now I'm going to actually show how a POS tagging is done. So I'm actually going to pick a random sentence, and I'm going to run. Okay, sure. How about this? I can make a, how about this even? Better? So I'm going to go this and, oh, not this. It just takes a millisecond, hardly a few milliseconds to do the POS tagging. So if you have a pipeline, let's say if you have a Spark, Apache Spark, and if you have a series of text coming in, and if you want to do parts of speech tagging on it and then do further processing downstream, it won't even see this taking any time at all. Sorry? Raise your hand, please. I can't see your face. Yeah. I can't hear you. Bigger. Okay. The file is in the GitHub, but you need to open the Jupyter Notebook using Anaconda. Yeah, yeah. So is this better, the text size? Okay, thanks. There is a, you have to click download and it actually downloads, and you have to close the dialog box. Okay. This is not a file, and I'm just opening a Jupyter Notebook. I'm copy pasting the instructions from the my presentation. So if you can just write the text, whatever you see it on the screen, onto your Jupyter Notebook. So that's one example. There's another example I can just do just to show how quick. So there's another sentence. They refuse to permit us to obtain the refuse permit. Now here is the interesting part, especially in NLP, if you have parts of speech tagging or NER or parsing. Here the word refuse, look at the word refuse. One is a noun, one is a verb. And let's see if it can figure it out. Okay, can you imagine how wonderful that is? The first refuse, it figured out it's a verb, a proper verb, VBP, and second refuse, it figured out it's a noun, a singular noun. Isn't it amazing? Isn't it just completely amazing how it figures it out? Unless you have text from a domain-specific text, like let's say healthcare text. I was talking to a gentleman by name David Talby, a very smart guy. He was the CTO of a healthcare company. He mentioned the English language has a vocabulary of 500,000 tokens, unique words being used, typically what we speak or we write or we read in books and stuff. Do you know the size of vocabulary in medical domain, English words, not the words derived from Latin and other stuff? Do you know how many words are there, English words that's being used in medical domain? Regular English language, what you and me speak, is 500,000 tokens, 500,000 vocab size. 50,000, okay. Any other guess? 5 million. 5,000. Someone said 5 million. 10,000. Okay. Someone said 3 million somewhere there. 3 million, you said? Okay. Any other? It's actually 3 million. 3 million words. Of course, they have actually created newer words which we don't use in the normal walks of life. We don't normally use that. But there are 3 million terms. But here is the complication on top. If you're working for a healthcare startup and are trying to do ML or using NLP on that, here is the complication. First of all, you have a lot more words. And of course, you have a bigger corpus you need to use for training. Doctors don't write the complete word when they're making a report. Sometimes they write an abbreviation. Sometimes they make a shortcut. Sometimes they may just have the shortcut which does not even refer to the original word, because the hospital in the 5th floor, you have a same team of 4 or 5 doctors, 10, 15 nurses, all working together for the last 4 or 5 years. They know exactly what the doctor is saying, and hence he will just say, hey, have you done X1? It could be whatever it is. X1 could be any damn thing. But, sorry for my French, but then comes the complication of how would you use NLP in such a context? PO is talking will fail there because it does not know what X1 is unless you have enough corpus of text to show what X1 is. But there are other rule engines which companies use, and we can talk about that if you guys are interested in offline. But that's the extra complication of okay, let's try to do another a simple use case. In a big massive book, let's say Shakespeare's novels. Have you guys read Shakespeare's novels? Yeah, wonderful. I'm actually going to show the result of a deep learning model which actually writes like Shakespeare. Shakespeare is dead, I guess, right? Isn't he? Yes? No? Dead, yeah. At least, I'm sure at least he's dead. So this model actually writes stories like Shakespeare because you can actually train a model. But anyway, in a big corpus of information, if you want to find similar words which appear in the similar context of the word you're looking for. Let's say the word you're looking for is IMAX, name of the theater, IMAX. John went to IMAX theater, or nice new movies are being played in IMAX today. If you want to find what words co-occur with the words which are in the similar context of IMAX, that is, if you look at the word previous and one word after, I want to find what comes in the middle in other instances for the same first word and same third word. Yeah, you understand the concept? Similar? And let's see how long that takes for that to work. So I'm actually going to run this again on my Jupyter. Okay, it went through. So I'm using the corpus brown. Let me go back to show the. So I picked up the brown corpus, which is one of the corpus available, and I want to find what words typically come before and after. No, what are the words that come similar to women in terms of the context-wise, where they have the first word and the third word being very same or similar or same. Okay, let's see. Brown corpus, I think, is, I don't know, 60,000, 70,000 sentences or words thing. So it picks up, I think, in hardly a couple of seconds. There are a lot of other types of processing you can do. I'm only showing a couple because 4 hours you can't teach too much of everything of NLTK because there's so many exciting things in summarization, question answering. I want to even share in my second company, but first AI company, we developed a solution that processes documents to compare document and also rank documents. That's a generic sentence. But in the process, what we also did was we did a little bit of a question answering. If you feed a bunch of text to the computer, neural network, deep model, and then after that you ask a question, it will answer the question. But the question cannot be, the president of United States is Donald Trump, and then the question is, who is the president of United States? No, that's not the question. Then you can just use a regular pattern matching. The story is the following. Let's say Sally went to the kitchen, John went there too, it was bright morning, Sally said a hi too. And if your question is, who did Sally say hi to? We all know the answer. But the model doesn't know. First, Sally is a human being, and there's another human being in the place. Model doesn't know where John is. Model knows where Sally is. Excuse me. Sally went to the kitchen, John went there too. So by doing a regular pattern matching, you cannot find the answer. So question answering is another interesting aspect, which I'll talk about that. So when we develop the model, there are a bunch of data sets available, but instead of taking the regular data sets, what I did was I took a massive Indian story. If you guys have heard of the story called Mahabharata. It's a massive online text available, maybe around, I don't know, 1 million, maybe 500,000 sentences. So we fed the model with that story, and then later on when you ask a question, it was giving answers, and the accuracy rate was 72%. That would be one of the use cases if you guys want to use the processing of the text. I'm only showing only a few, but there are so many other activities you can do. So that's why when you go home, I think you should work on that. Yeah. Yeah. Let's say you're in a healthcare situation. You want to find patients who have similar symptoms like David. Now, David has, let's say, 2 symptoms or 2 situations or 2 whatever. Let's say David has hypertension and, I don't know, headache. In a sentence about other patients, the word headache may not be the same word they use to refer to headache. They could be other words, number 1. Number 2, similarly to hypertension too. Number 2, the word just before the patient name, patient 1, patient 2, patient 3, and the word just after patient 1 may not be referring to headache or hypertension. When you run this type of, you have to do a little more processing. What I'm showing right now is just purely pick the first and the third word. But if you do a little bit of a rule engine, it's picking up words which are very similar to the context what you're looking for. So that's one use case where you want to find similar patients. You want to find similar situations or similar cities which has the same set of entertainment or attractions, what you're looking for. Or flights which are in the similar prices. If you're trying to take a flight from A to B, those are some situations where you have a bunch of text, you can do a similar, extract the information what you're looking for, maybe even get the sentence, and then do further rule engine to process and find the information. That's one couple of use cases I can think of. It is, yes. The example I just gave you about training a deep neural network on that my Mahabharata story, 72% accurate means 28% of the time it's giving a wrong answer. I'll give an example of machine translation which Google has come out with, I think 6 months ago. All my solutions which I'm going to be sharing are all papers, technical papers. Even some of the latest fantastic models are not 100% accurate. So when you are using NLP for non-regulated, non-life-threatening problems, it's easier because you can afford to have a little bit of inaccuracies. The biggest concern, and hence most investments by VC funds into healthcare, is because it's a life and death situation. You can't make an error, and hence making sure that the model picks the right answer for your question is a quest still going on. People are not figured out. I will give you another solution where in a translation, machine translation, language translation, to increase the accuracy, you can add a concept called language model, which is actually relatively new. And I will talk about that. That's why I said the implementation details, if your system is not working, if you're not able to install it, don't worry, you can go home and do it. But I want you guys to, when you leave today, leave with the concepts where you are absolutely sure what a sequence-to-sequence model is. When would you use that? Would you use an RNN versus LSTM? Why would you use an LSTM versus GRU? That concepts I want to clear today. When you guys go home, you can kickstart your learning quest on NLP. I've done a similar training in a different conference the other day, and it was 3.5 hours. And the title, I was trying to look for a funny title. I said, 9 months of NLP in 4 hours. What I'm teaching today is actually, I took almost a year to learn and understand. And in 4 hours, you guys are ready, hopefully, to listen to whatever I'm speaking. Long time ago, I had a favorite boss in my company. He used to say, if I give you a message, for the message to be 100% understood, I need to repeat the message 7 times. So please sign up for 6 more times for this conference next time when you come, because to get the message completely. So it is actually lots and lots of concepts I'm going to be talking about. And because there are a variety of people in the audience, some are really good programmers, some people don't have a clue what NLP is, some people have an introductory information, some people are intermediate, they actually know some of stuff and they want to find out advanced techniques. I'm actually trying to cater to all of those, but the underlying concept for every one of you is, what are some of the fundamental concepts that are the building blocks to construct an NLP-based solution, whether it's your healthcare solution or a transportation case, whatever it is you're trying to do, you will be able to, I think you will know at least 10-20% of that when you go home and start using that. So when you start reading up a few blogs, a few papers, you will be able to better understand. And also I have a stand on these papers. I'm sure you would have seen lots of papers, technical papers. I know you have a comment, I'll come to you. All the technical papers are written not to teach you. They're written to show how smart the author was or is. So you will not be able to learn from the papers, at least when you are in a beginner stage. When you are intermediate and advanced stage, yes, you can pick up the papers, because there's lots and lots of math. I will be using some math today, but I'll try to not to use as much math, because you guys all like math? Yeah? Okay, fantastic. If you guys like math, I'll tell you a math story. But before that, can you go to your question? Yeah. So when it picks up, it actually tells you the location where it's picking it from.
Visually, I mean, this is coming from the real case. When I give the answer giving the answer for my customer, the customer immediately wants to go to all the places.
Yes.
So then it becomes like a application I have to integrate with some other tool.
Yeah.
To be Elasticsearch.
You got to do some more programming on top to actually get to the links where it is, but it actually knows. I'm not showing that part. It knows where it's picked up from. Yeah, you got to write an additional program for that. Yeah. The question is, for the similar example, what I just showed, similar when I picked up instances where the word found similar instances, instance 1, instance 2, instance 3, and if it's picking up from 3 different documents, can I also link that document so that if I want to do further deep dive, can I find the links? Yes, it knows, but you need to do an extra programming to find out what the link is. Yes, it knows. Okay, you talked about mathematics, but before we go to the mathematics, what time do you guys want to take a break? If you want to take a break now and come back at 12:30, that's fine too, but I just want to know. Maybe, yeah, let's take a break, maybe another half an hour. Is that okay? Yeah, okay, mathematics, you guys right, eh? And this is not NLP, so you can put your computers away, and then I said, oh, thank God. Have you heard of a concept, mathematical concept called Monty Hall problem? Yeah? Okay, fantastic. Let's talk about that. If you do, people who have not heard of it, it's like a game show where you have 3 doors and you have a fantastic gift kept behind one door like a car, and one from the audience will be called and asked to pick a door number 1, 2, 3, and then everyone is clapping and it's all excited because if you pick the right door and if the car is right behind the door, you get that car. Yeah, it's so exciting. Have you seen that? So let's say there are 3 doors. You are the participant, each one of you. I want you to imagine each one of you are the participant, and the car on the other side is actually the Tesla, the best, recent, most Tesla. Okay? To make it exciting. And I am the organizer, and I ask you, okay, what's the door number you want to pick? And out of 1, 2, 3, you pick a door. Yeah? Let's say you pick door number 1. To make it more exciting for the audience, what the organizers do, the game shows, is they open one of the other 2 doors randomly, which does not have the car. Typically, they keep goats, and that's the multi-hall problem is actually goat, but it could be any other funny thing too, some cheap item. So let's say they open door number 2, and there is a goat behind door number 2. Now we have 2 doors to pick. You already picked one, which you can allow to change if you want to, and there's door number 3. You don't know which door has the car. Now, the organizer of the game, he says, okay, do you want to change your choice? Do you want to still stick with door number 1, or do you want to change to go to door number 3? If you are a mathematician, what is the recommendation? Someone said change. Doesn't matter. No, just pick a door. I know it's a. You switch? Okay, fantastic. Anyone else? You keep number 1 or you switch to 3? Switch 3, okay. Keep 1. Switch. Okay. The mathematical answer for this is it's always a better idea to switch. The probability of you winning becomes 66% if you play the game multiple times. It's of course a theoretical game because you'll be only given a chance once, so you don't know whether to switch and keep. But if you're a mathematician, because all mathematicians always think they can repeat the game multiple times, yeah, which is not the case all the time. But the probability of winning a car goes up to 66% if you switch, and remains 1/3, that is 20% or even 33% or even lesser if you keep what you already picked. I won't explain what it is. Go back and check online. But I wanted to tell you the story just because you guys said you like mathematics. But okay, so let's go back to our regular stuff, what we came to study. So there are other examples of similar, but I'm not going to show those. Okay. In English language, you have all the words, and each word communicates a message, and you want to extract the word, you want to find out the word, you can do a parts of speech tagging of the word, you want to do a named entity recognition, NER on it. But there are some words which don't actually give any meaning, like in, the, a, an, of. Sometimes they may give a meaning because it actually modifies a verb or noun or whatever, but many times they don't. These are called stop words. Every NLP tool like NLTK, Core NLP, they actually have collected a bunch of stop words, and you can eliminate those from the text so that processing can be better. You can also modify what would be a stop word, what should not be a stop word, but this is an example of how to identify the stop words. I'll just show you what the stop words are. So let's go back and I will just show you what are the various stop words available. So I'm importing all the stop words, and then I'm going to actually, and these are stop words for English language. They have actually corpus for other languages too. Of course, the most frequently used language is. So these are some of the stop words which the model feels I don't know how to do this. Okay, you guys see, hope the font you can see. These are some of the stop words the model or the framework believes it's not going to help. And you can eliminate these stop words in one single stroke. And if you feel some of the words are useful, you can keep them, but you need to just go back to modify the dictionary of the stop words. Okay, let's get to you might have heard of something called sentiment analysis. Every company does sentiment analysis.